Video, we're going to talk about bar graphs and pie charts. Most of us are familiar with them, but let's kind of explore them a little bit. So let's look at this pie chart here. And they ask, which slice is the biggest? Now, I had such a hard time telling the difference between the red slice and the blue slice. And I printed mine out and got a ruler, and to me, they looked the same. So for me, I'm going to actually say that they are the same. I'm going to say the blue and the red are both the biggest slice. All right. Which one's the smallest? Well, to me, that's a lot more clear cut. That would be the green one. All right. So if the whole pie represents 100%, how much do you think each piece is? Okay, now I'm going to kind of see that this blue piece here, it looks like when you combine it with the red and the green, right? That they form half, right? And then the red and the orange one form the other half, right? They look like it's split right down the half mark there. But then since those two kind of look equal to me, that would mean that these three here kind of form an equal piece as well. So to me, that means that they almost break it up into like thirds, right? Blue's about a third of it, red's about a third of it, and the other three make up the final third. Okay, well then, if I'm thinking it's about a third, if I take 100 and divide it by 3, that's 33%. So I'm going to actually label them. Let me use a black to do this. Okay, so I'm thinking that this one is 33%. And I think this one is about 33% as well. Okay. So then the other pieces here look like they kind of make up the rest. Now, I just kind of finished saying that these two look like they kind of cut it in half, right? The red and the orange kind of combine together to cut it in half. So I feel like if that's 50%, that would mean that the orange one would be about 22%. All right. Now I'm left with the red and the green. So the red looks like it's a little bit bigger than the green. All right. And so therefore, I'm just going to try to make it a little bit bigger. So if those two total up to 22%, how about I say that the purple one, I think I said red and green and I meant purple. Wow. Purple would be 12%, and then the green would be 10%, because those two total up to 22% as well. All right. And there we go. That's pretty good. Those all add up to 100. I could verify that they all add up to 100, but they do. And that's kind of how I could figure out loosely what they would make up for this. Okay. So now let's take a look at a bar graph instead. So in this case, we definitely have a clear cut, bigger. Barely, but it's definitely bigger, and that would be the bar that's represented by A, just a tiny bit bigger than B. And then the smallest one would be D. So they're going to kind of ask the same question. If they represent 100%, how could we break this up? All right. So in this case, then we're going to have to use the sizes of the rectangles to kind of help us determine that. So like, for instance, when I compare B and C, C almost looks like it's maybe half. Almost. Maybe if I extend it to A. Okay, so C definitely looks to me like it's half of A. So whatever A is, C is about half. Okay. D looks like less than half of C, right? Less than half. What about E? Let's compare E with C. I'd say E is close to half. So E looks like it's close to half of C. All right, so we're kind of using that. And we are being a little bit of a rough estimate here. And D is definitely smaller than E. All right, so we want them to add up to about 100%. So I'm going to kind of assign some values and then start adjusting based on wanting it to add up to 100%. All right, so let's just say for right now that D is 10%. Okay, E is a little bit bigger. Let's say it's 15%. Maybe should be less than that, but that's all right for right now. That would mean that C would be about 30% since it's twice as big as E, right? And then A would be 60%. Okay, so let's add those up and see where we're at. So that's over 100% because 60 plus 30 plus 10, that's 100% right there. Okay, so we're definitely too big. So let's change D and let's go to 5%. All right, so then how about E? Let's say that one's 7%, a little bit bigger. Okay, that would make C 14%. And that would make A 28%. Okay, so let's add those up and see what we got. 28 plus 14 plus 5 plus 7. Let's see, that's 54%. Okay, so now we're way too small because that's what's left over for B is too big. But we're getting better now. All right. So let's go ahead and let's say, how about D is 8% and E is 10%. That means C would be 20 and A would be 40. Okay, so let's see. That's going to be 78%, which would leave for B 22%. And that doesn't quite work, right? Because 22% is barely bigger than C. Barely bigger than C. But at the same time, it should be closer to A. Okay, so now I'm going to kind of adjust A then. So based on that information, I kind of feel like maybe A should be closer to like 30%. Let's see. If A was 30%, so I'm going to erase that. That would mean C would be half of A, so that's 15%. E is about half of 15%. So now here I'm going to round that. I'm going to say it's 8%. And then since D is a little bit less than that, I don't know, let's say it's 6%. Okay, so let's see where that lands us. 30 plus 15 plus 6 plus 8, that lands me at 59%. Still too small, but we're getting warmer. Okay, so let's do 36%. I'm picking a nice even number so that I can cut it in half. So that means C would be 18%. Half of that is 9%. And then here, let's just see where that is before I figure out D. Okay, so 36 plus 18 plus 9 gets me to 63%. That's not bad because that leaves me 37% left over. And I feel like this should be just a little smaller. Maybe 33%. And that would mean this is 4%. Okay, so we're getting close. I'm feeling a little better about this. Okay, now I approximated. So I'm going to go ahead and rather than say that this is 4% and this is 9%, I'm going to decrease this one to, let's see, if I decrease it to 8 and 5, that might feel a little bit better. Okay, so 5, 8, 18%, it's close to half. And then 33%. Okay, I feel like I could live with these values. They're not perfect, but they're relatively close. And I hope you kind of see how I played that game to kind of figure out which would work. All right. So you might have noticed it was difficult to answer, and that's true. That's because pie charts are good for part to whole comparisons, but bar graphs aren't so good. So I had a much harder time doing the bar graph than I did the pie chart. I was able to use geometry for the pie chart, but figuring out the bar graph, I kind of had to just keep guessing and checking. All right, so that means that percentages work better for pie charts, but comparing sizes of groups is better for bar graphs. All right, so it happens to be that the data is the same, which means if that's the case, if the data is the same, then these two sectors, oops, it kind of moved because I moved my screen, I'm sorry, that these two sectors that I was working with earlier, which I said was 33% for both of those, were actually a little bit different. That's good to know, tiny bit different. Okay, which color in the pie chart represents the letter on the graph? Okay, well, that's nice and easy to figure out then. So the A would be the largest. And we didn't pick one to be the biggest. So if we were to take a guess, and I really am guessing at this point, I'm going to say red just for right now. I'm going to go ahead and alter my answer to say that red is the bigger, and therefore red matches A. All right. That would mean then that blue would match B. Orange would match C. And then it goes purple. Sorry, it gets mad at me when I move. Purple is next, and that would match E, and then green would be D. So purple would go with E, and green would go with D. All right, so let's decide which would be easier to illustrate with a pie chart or a bar graph. So the weight of tests in your overall course grade. So which tests are worth more? But then of course, you also want to kind of see it as a whole percent. So that's really the question. Would it be better to see the tests as what percent it contributes to your grade? Or if we want to see them compared to each other in terms of how big they are. And I think that when we typically want to think of the class or how your tests are, you want to kind of think of it as the whole, right? So I feel like percentages make better sense, and therefore pie charts would make more sense. Your performance on tests compared to your performance on homework. Okay, so the word compare makes me feel like we should be thinking bar graph, because we'd be kind of looking at those scores compared to each other. The categories of your budget, which has the highest spending. Okay, so when we're thinking about what we spend the most on, what most of our money goes to, a pie chart actually makes most sense. It's typically when you look at like spending information, like if they say how much you should spend on like rent or your home, they'll say 30% or so, right? 30, well, that's already a percent. So we want to kind of think of that as a pie chart. The aspects of your lifestyle and their relative contributions to your overall carbon footprint. Okay, so now that aspects of your lifestyle and their contributions to the carbon footprint. So I'm feeling like that's a bar graph, because we'd be seeing how one thing might be a far greater consequence than another, meaning much bigger than another. One thing we do, like driving our car versus snoring at night, right? Like those two things are going to have a different contribution to the environment. And when I compare one to the other on a bar graph, I can see that one is much bigger than the other. The relationship between your transportation carbon footprint and your food carbon footprint. Okay, so again, bar graph. And your carbon footprint compared to the average carbon footprint. Again, I feel like a bar graph. So I feel like if we're going to do comparisons, we really do need a bar graph. I think then that we might be able to argue part D could possibly be a pie chart, because we could see which ones are overall having the largest impact in our own life, since we're talking about just our lifestyle. So it might make sense to say pie chart for part D. So here, I'm going to put or pie chart, because I think you could say there's an argument in place to say that it would work a little bit better now that I'm kind of rereading that question and comparing it to the other two. Okay, so let's create a bar graph and pie chart for each description and use a straight edge. Now, unfortunately, I cannot use a straight edge. You should use a straight edge. Do the best you can. But if we wanted to do that, a sweater is 55% cotton, not 40% nylon, and 5% acrylic. So we kind of want to think of it as, okay, so if half is 50%, right? If that's half, and don't, you want to kind of change it to be a little bit bigger than 50%. So if half is 50%, so then let's say that we go just a little bit bigger. So that will be cotton. And then 40% nylon. Well, that's going to make up the next really big chunk, right? 40% is quite a bit. So here, I'm going to make it much bigger. So this will be the 40% nylon. And then this last little one will be the 5% acrylic. And that's kind of how I would break it up. It's probably not perfectly accurate, but it's a good enough job. It's getting a rough idea for each. Now, if I'm going to do this on a bar graph, it actually makes more sense to kind of create tick marks on the bar graph itself, like to give me something to kind of work from. So like if that's 10%, oops, and that's 20, 30, 40, 50, 60. So it might make more sense to kind of give me some labels to work from for the comparison. All right, and then down here will be cotton, nylon, and acrylic. All right, so when I create then the cotton, I want to go to in between the 50 and 60 for 55. For nylon, we want to go to 40%. So I'll line that up. I'm going to do my best to make my rectangles look the same. Of course, because I'm not using a straight edge, I can't. They're going to be a little bit rough, but I'm going to try to make them about the same width. And it helps too if you kind of color them in. So here I'll do a really bad coloring in job there. And then acrylic being 5%, well, that should be like half of the 10%. There we go. All right, and that's the best I can do freehanding it. All right, and then they ask you to do this again. This time we're going to be looking at more, and we're going to kind of need to squeeze them in a little bit better. 35% white, 25% black, 17% Hispanic, 12% Asian, 3% Native American, 8% other. Okay, so we definitely need to break this up a little bit differently. So 35%, that's close to a third of the circle. So I'm going to kind of break this as best I can up into a third. Probably should be a little bit bigger. That's as close as I can get. Okay, so that'll be the white. Oops, there's a T. And that's 35%. Black is 25%. Okay, so 25% is actually easier. It's kind of like a little quarter of it. In fact, a quarter might have been easier to have done. Here, I'm actually going to do it like this. That looks like a very sad straight line. It's supposed to be a straight line. There we go. That definitely looks like a quarter, that top one here. So that'll be 25% black. Oops. Okay, looked a little sloppy. Okay. And then it goes 17% Hispanic, 12% Asian. All right, so 17 plus 12, that adds up to 29. That's quite a bit. All right, so 17 needs to be significantly less than 25. Not significantly, but less enough. We'll go ahead and put it about there. 12% should be half of about half of 25%. Actually, here, I think that's a little bit easier for me to visualize. So here, I'm going to kind of visualize a straight line here. That was an attempt at dotting it. Dotted straight line. 12% is going to be about half of that sector. So sloppy. All right, that's the best I can do. All right, so that's about 12%, which was the Asian, 12% Asian. Okay, now 17% should be bigger than that. And maybe about there. And that is Hispanic. And then Native American is the smallest of all of 3%, and then 8% white. So I'm going to go ahead and kind of make a little sector. Wow. Shows how tough it is to draw straight lines when you're freehanding it like I am. Okay, so this would be 3% Native American. And then this category would be the 8% other category. All right, there we go. Best of my ability, squeezing it in. Okay, now for the bar graph, it's a little bit easier if we just do like I did before and use little tick marks. This time I'm going to go by fives because 35% is the biggest. So 5, 10, 15, 20, 25, 30. I need to go up to 35. Wow. 5, 10, 15, 20, 25, 30, 35, 40. There we go. There should be percentages here. 25%, 20%, 15. Wow, I did it wrong. Can you tell I'm tired? Start from the bottom, Allison. And I erased some of them. Okay. 1, 2, 3, 4, 5, 6, 7. All right, so that should do it. So 5%, 10, 15, 20, 25, 30, 35. Yay, I finally did it. Okay. Now for each category, since there's not a lot of space, I'm going to go ahead and abbreviate each category. So this will be W for white, B for black, A for Asian, H for Hispanic, N.A for Native American, and O for other. All right. So W, B, A, H, N, A, and O. All right. So this is, I'm going to do my rectangles a little bit skinnier since I have more categories. There would be white, black at 25%. I kind of semi-adjust since I did a little bit too big. Asian was 12%, which would be closer to the 10% than the 15%. Let me try to draw that. H is 17% for Hispanic. So that should be closer to the 20%. There we go. Native American is 3%. So that should be a little bit below the 5%. And then other 8%, that should be close to the 10%. Oops. And there we go. That's kind of roughly how it would look, not getting to write out all of the words. And that's how we would do pie charts and bar graphs for each piece of data.